Hi, my name is Chris Applegate, and I'm a solution architect here at the Customer Solution Centers. In the Customer Solution Centers, we work with account teams to directly engage with customers and demonstrate the value of the Dell Technologies portfolio. In doing that, we've built a network of 19 locations throughout the globe, and these are places where account teams can bring customers to have technical conversations. These conversations can range anywhere from short briefings, all the way through architectural design sessions and whiteboards, and even into proofs of concept, where we can host equipment in our labs anywhere in the globe, and you can access it and kick the tires of your solutions prior to purchase. All of this is available at no charge. I'm here to talk to you today a little bit about Dell Technologies' multi-cloud strategy. And if we rewind the clock about 10 years, you can hear the earliest incarnations of us talking about Dell's cloud strategy, and as customers began to embrace and adopt the cloud IT consumption model. A couple of years after that, we started to talk about hybrid IT, where you had an on-premises instantiation of a cloud as well as leveraging a public one. Well, now we've moved into the multi-cloud era, and this is based on direct feedback from our customers. When our customers were asked how many of our customers are using more than one cloud today, over 80% of them said that they were already doing that. Further, of that 80%, over 90% of those customers said they were using 5 or more clouds already. So the idea is multi-cloud is already here and our customers are using it. So we have to ask ourselves, what are the forces that are dictating to our customers that they need to be able to leverage resources in multiple locations? We've codified that into what we call the 3 sets of laws. The first set of laws are the laws of physics. So the laws of physics, things like network connectivity, network latency, data volume. The classic example here would be with network connectivity. You might not have prevalent network access at every location you need to run your workloads. Classic example would be an oil platform in the Gulf. They're not going to have high-speed bandwidth in order to wait for a decision to be made in a remote public cloud and arrive back at them. At the same time, the latency can be sensitive. When you need decisions made in a very short amount of time, oftentimes waiting for someone else's infrastructure to process that and return that result to you makes that not an option. And then lastly, when we think of data volume, sometimes when you need to push hundreds of gigabytes or terabytes or even more in order to do a data processing or data analytics job, you again don't want to wait for that time necessary to transit that data and derive at a result. Right? The next set of laws that we talk about are the laws of economics. So the simple costs of compute, storage, and networking are such that it doesn't make financial sense in order to leverage somebody else's infrastructure and lease that time. No product in the history of mankind that you intend to use for longer than 16 to 18 months doesn't make a tremendous amount of sense to lease from somebody else versus purchase outright. Right? Whether it's a house, a car, or even your compute time, it probably makes more sense to keep and manage that infrastructure where you can enforce your own financial controls versus paying somebody else to do it long term. The last set of laws that we look to are the laws of the land. This is things like governmental requirements around privacy, around data residency, and even around taxes. All of these can be forces that are requiring you to have to move your workload at any given point in time. Classic example would be some of the regions inside EMEA. Places like Germany require that all information stored about their citizens must be held in data centers that are located in Germany. If you've partnered with a public cloud that doesn't have endpoints in that location, does that mean you can no longer do business in that country? Right? Imagine having the ability to move it as these forces start to change and evolve. When you look at these sets of laws, the one thing you don't see up here is technological limitations. So when we look to what technology we can leverage in order to facilitate movement of our workloads simply based on these forces instead of on technical limitations, we look to the Dell Technologies software-defined data center. And when you think of the software-defined data center, it starts with software-defined compute. And this we've been doing for years using technology like VMware's ESX. When you look to software-defined storage, this is technology like VMware's vSAN. And finally, when you look to software-defined networking, this is where you can leverage the power of VMware's NSX. When we take all three of these software-defined technologies and wrap them together in the software-defined data center, this is what gives us the portability to move our workload where we need to based on these three sets of laws and not the technical limitations. Now I'm going to talk to you a little bit about what the Dell Technologies portfolio looks like that can help enable this movement and this portability. Well, we first have to ask ourselves, what are the three types of locations that we need to run our workloads? And we'll bucket those into about three different sections. The first one is the one that we probably know the best, and that's my data center with my IT staff. In this case, we'll call that core. Well, then obviously there's somebody else's data center with somebody else's IT staff. We call that cloud. And finally, what about locations where I may not have any data center or any IT staff? We'll call that edge. And what I'm looking to do is I'm looking to establish a level of consistency across all three of these locations. And when I think of consistency, I think of consistency at a couple of different levels. The first one is consistency in infrastructure. When I think about a virtual machine, it has certain properties to it. The fact that I can add vCPUs to it elastically, I can add memory to it, I can scale up its storage. These are the properties of a virtual machine. And it would be great if I had those same properties in every one of these locations versus maybe when I look to one location, I can't add memory in the same way. I can't scale out the storage. Right? It doesn't behave by the same properties as all of the other locations. What this allows me to do is then further standardize on a consistent set of operations. When your operations teams need to do things like restart a virtual machine, it would be great if you could capitalize on a single skill set rather than needing to train them how to restart a virtual machine in this environment, separate console, separate tool to restart a virtual machine in this environment, and even a further one out in this. Right? Having the same type of infrastructure allows me to enforce the same type of operations, whether it's a person that is doing that operation or even leveraging an API. It allows me to use the same automation in all of the locations. What this allows me to do now, finally, is establish a consistent set of services to my end users. When we think about what types of services, they all ride above this level of consistency. It could be that your users are bringing you virtual machines to run. Well, you can stand up on this consistency layer and infrastructure as a service. Maybe they're a little bit more advanced and they're bringing to you containers or Kubernetes pods. This is where you can stand up containers as a service. Maybe they're not delivering you pods or virtual machines at all and they're a software developer. They're bringing you source code. Here is my source code. Please run it in a cloud. I do not care how. This allows you to stand up a platform as a service. Maybe the amount of code they're bringing you is a small fragment, as small as a single function in programming. They just need that function run at scale. maybe 1,000 times, maybe 10,000 times, maybe 100,000 times as events arrive. This is what we call functions as a service. And finally, maybe you consume commercial off-the-shelf software, and your vendors deliver you a full turnkey software solution, and you stand up on top of this stack, software as a service. The fundamental idea here is that all of these services ride above the layer of consistency, allowing all of this to change, the location to change, etc., without impacting the services that you provide to your end users. So how do we deliver this level of consistency using the software-defined data center in Dell Technologies in each of these locations? Well, let's start with the software-defined data center that we can stand up in my data center with my IT staff. Well, we can look to VMware's Cloud Foundations, right? This is a full turnkey suite of everything needed to run the software-defined data center on a stack of equipment in a data center of your choosing. It handles the lifecycle maintenance of all the VMware elements. When I connect that VMware Cloud Foundation to a VxRail, now I bring in the hardware automation and the ability to do a single turnkey update of both my VMware software as well as the underlying hardware, completely transparent to my users. This is the fullest instantiation of automation and lifecycle maintenance. But it's not the only option for our customers. Some customers need a little bit of additional flexibility. So this is where we can use VMware's validated designs. And this builds on things like the vSAN Ready node from Dell Technologies, where while you lose some of the automation and lifecycle maintenance, you're at least working with a completely validated set of hardware components. You don't need to worry about if a particular model of firmware works on a particular model of an SSD when attached to this model of controller on this type of server running this version of BIOS. All of that can be handled for you when you go with a validated design and validated objects like vSAN Ready nodes. But yet again, some of our customers need further levels of flexibility. This is where we can still enable our customers to do it themselves, right? We make the greatest bricks in the business. If you want to build your house out of those, we're going to do everything we can to help you. But you are going to have to assume more of the risk here and more of the burden on your IT staff to do things like the validation and lifecycle maintenance, because you've given those up. As you move down this list, you're increasing your flexibility for sure. And you may even be reducing your costs short term, but you're also increasing your risk. Right? It's up to you and your IT decision makers to determine where on this spectrum you want to lie, given your appetite for flexibility and for risk tolerance. So now let's leave our data center with our IT staff, and let's move to somebody else's data center with somebody else's IT staff. What if I want the software-defined data center experience from VMware in one of the public clouds? Well, here I can look to VMware's managed cloud. Well, which public cloud? Pick your poison, right? For a number of years, we've been delivering the VMware managed cloud on AWS. At Dell Technologies World in 2019, we announced the ability to do this on Azure. Right? And we even announced at VMworld 2019 the ability to do this on Google. And we have the ability to do this on a whole variety of other cloud service partners. Right? The idea here is that you have flexible choices as to where you're implementing your solution and where you're moving it. And you can move across these seamlessly as the three sets of laws dictate. As costs change to be more advantageous from one vendor to another, the software-defined data center gives you that portability to pivot and move to another one of those locations. Well, what if I want this managed experience where I don't have to worry about any of the underlying hardware components? I'm not managing any of the firmware on it. I'm not managing the software elements. I'm simply consuming the service. What if I want that type of experience, but I need to do it in a data center of my choosing? Maybe a data center where I don't have any IT staff or a real semblance of a traditional data center. This is where we can look to the VMware Managed Cloud on Dell EMC. Think of this as a half rack or a full rack of equipment that arrives to your site, figuratively, welded shut. You don't have to worry about any of the elements inside it. You're not responsible for the maintenance of those. You're simply, through a cloud-enabled portal, consuming those services at that site. All the workloads are running there in that rack and local to that site, but you can do command and control transparently from anywhere in the world. This uses some of the best-of-breed technologies from recent acquisitions inside Dell Technologies, including VeloCloud's SD-WAN, that enables you to extend your wide area network over things like the traditional internet while still maintaining security and compensating for the quality and line conditions that are prevalent on the public internet. So hopefully you've seen here that Dell Technologies' multi-cloud strategy gives you the ultimate flexibility, both in the location of your choosing, as well as in your appetite for flexibility and risk tolerance. If you'd like to come and talk about your options when it comes to multi-cloud, please go ahead and reach out to your account teams to book an engagement in the Dell Technologies Customer Solution Centers at any one of our 19 global locations. Thank you.